Hey, my name is Adrian Vaz,
My name is Gabriel Hidalgo.
and today we are going to present to you how the sine graphs work, their elements, and the transformations that can exist.
Okay, let's begin with sine graphs. Our simplest formula for a sine graph will be y equals sin times x, but we also have a more expanded formula in which we can see all the transformations that it may have, which is y equals a sin b times x plus c plus d. A in this function represents the amplitude, b represents 2 pi over the period, c will be our horizontal shift, and finally d represents the vertical shift. This is our simplest formula, and here we can see the graph that this represents. The most important of this is that we have 5 key points, which are 0, pi over 2, 1, pi, 0, 3 pi over 2, minus 1, and 2 pi, 0. These are very important key points because with this we can do all the transformations later.
So the first element that we will analyze is the amplitude. The amplitude is known as the distance between the center line and the maximum, or as well to the minimum, or as well it can be seen the distance between the maximum and the minimum divided by 2. And in the parent function, the amplitude is 1 because the distance between the center line and the maximum is 1, and as well the distance between the center line and the minimum is 1. But if the amplitude will be, for example, number 2, the maximum will be changed to be 2, and the minimum will be changed to be negative 2. So the graph will go like this. The period is known as the distance between one peak until the other corresponding peak, which means the end of the graph. And, well, the period has a special formula, which is period equals 2 pi over b. And in order to get the period, we need to look out on the letter b, first of all. So, for example, in the parent function of a sine function, the letter b is implicit, which is number 1. So, when getting the period, we need to make the formula 2 pi over 1, which means that the period of the parent function of the sine function is 2 pi. And this is why the function goes from 0 to 2 pi. And, for example, if the sine function changes the letter b, as well, the period will change. If the sine function has 1/2 x, we need to use this formula in order to get the new period, which will be period equals 2 pi over b, period equals 2 pi over 1/2, and this gives us period equals 4 pi. This will mean that our new graph, will have to go from 0 until 4 pi.
Okay, and now for horizontal shift, what we see for defining this is the letter c. This will indicate us if the function is transformed to the right or to the left. We have like this example in which we have y equals sin times x plus p over 2. This transformation will move all the graph to the left p over 2 units. This is because when you equal the x, it is minus p over 2. So all the graph will move to the left like this function. And in the other case, when we got a positive negative number, the graph will shift horizontally p over 2 units like this one. The vertical shift, which means how many units does the graph changes either up units or down units. So if the function has a number adding outside of the function, it means that the graph will go units up. For example, in this graph, it means that the sine function will go 1 unit up, which means that all of the points of the parent function will shift 1 unit up. And if the function has a negative sign with a negative number, it means that the parent function will change down by the number of units that it says on the function. For example, in this function it says -1, which means that the function will go 1 unit down.
Now we're going to see its transformation when it's reflected on the x and the y axis. First, we're going to see what happens when the function is reflected on the x axis. The key point here is that the reflection symbol that's going to be a negative sign will be outside the part that is called the sinoidal equation, an equivalent that has a sine or a cosine function. This negative, what will cause when it's graphed is that all the values that are on the y will change down to its opposite. For example, the first minimal value, if we say it's 1 and here it's -1, if we reflect this original function on the x-axis, the maximum value will become the first minimum value, and the first minimum value will become the first maximum value. On the other hand, when we graph it with a reflection on the y-axis, that happens when the negative sign is inside of the sinoidal function, the graph will reflect over the y-axis as if we folded over a sheet of paper. The maximum and minimum values will stay the same, but the values where the graph crosses will become negative.
Now we will solve a problem that has all of the transformations that we have been seeing during this video. And first of all, we need to get the amplitude of the function, and the amplitude is the absolute value of a. And in this case, a is the number 2, -2, so the absolute value will be 2. Now we will find the period, which in order to get it, we need to use the formula 2 pi over b. As we know, b is 2 pi, and if we use the formula, we will be having 2 pi over 2 pi, which is the number that is over there, will be 1. So our period is 1.
Okay, talking about horizontal and vertical shifts, we will analyze in our formula this number and this number. First, for horizontal shift, we saw this, and what we first do is solve for x, and here we have x minus 3 equals 0, and x equals 3. So now that we solve for x, we got 3 in a horizontal shift, and so this means it will be 3 units to the right. And for the vertical shift, the only thing we do is see the last number that is added to the formula, and since it is a positive number, it will go units up, in this case 2 units up.
As in an example, you don't need to be fully precise with your scale, but at least label everything. For example, we know that our vertical shift will be 2 units up, so we know that our starting point for the equation will be 2 units up. So we know that our average value will start at 2. We know that it has a horizontal shift of 3 units to the right, so we label here 3, and we have the starting point for our period. Then I will label here in red. That will be our first key point. That is 3,2. Now we can find our last key point by knowing how long the period is. We know that the period is 1 unit long. So we know that all our key values are going to be inside this interval. So the next step is finding the rest of the key points. That will start with 3,2 and end with in 4,2. Now, if we divide a period in 4, we get its segments, and we know what will be the difference between every key point. So the 1 divided by 4 equals 1/4. So the next point will be 3 1/4, and the maximum value will be 4. So we know that it will grow until this point. 3 1/4, 4. Then we know that the graph will return to its average point. So it's 3 1/2, 2. And then the graph will make the same distance from here to here, but in negative for the next point. So it will be 3 3/4, 0, and return to the average, but on 4. Now that we have all our segments, we connect the dots and have our first period. And from this period, we can copy the design for the last part. And read out the next for aesthetic purposes. And that's how you graph a sine equation.